Okay, we continue on with our sinusoid examples, and in this, again, we come back to electrical circuits. And it says electrical circuit is comprised of a voltage source as well as a resistor and an inductor connected in series, and the voltage drop measured in volts across the resistor at a time measured set is given by. So the resistor voltage is given by VR of t, which is 6 times the sine of 2t, and the voltage drop across the inductor is V of L of t is 8 times cosine of 2t. And now in the past we used, this would be in the case of alternating current. In the past we used DC current, we didn't have to worry about these things. When you have alternating current, that's where you should have to start getting these sinusoids involved, and that's why I said before, we really like to work in direct current because it's easier, but the world doesn't for other reasons, and it just makes the math a little more complicated. We get some sinusoids in there, so we have to understand how to do those things. And so the things we do know is that the voltage provided by the source is given by V of t is basically just the sum of the two resistances. And it wants us to express that as a single sinusoid. And so that's something we haven't done yet. So yeah, here's our circuit. We've got a voltage source, we've got a resistor, we've got an inductor, we've got what the individual ones are. We know that because of Kirchhoff's laws that the total voltage drop has to equal the same as the source, so our voltage must be, that says equal, should be plus. And it wants to express that as a single sinusoid. So remember, a single sinusoid is going to look something like that, where V of t is A times sine omega t plus phi. We have to figure out those parameters. And so there's not a really quick way to try to figure that out. We know, okay, I have these two things together, so I know V of t equals, the resistor, which is 6 times the sine of 2t plus 8 times the cosine of 2t. But there's not a simple way that I can just add sines and cosines together. Things that do help me out is I can only combine if omega 1 equals omega 2. So in other words, that's omega 1, that's omega 2. So since the since that omega term is the same on both of them, that is the first thing that just gives me a chance to try to figure it out, since the angular frequency is the same. If they're not the same, it gets really complicated because you don't have the same things happening. You don't have the same rate, so it's almost impossible to do it. So here we do omega is equal to 2. So that's very helpful. All right. So then we're trying to figure out things to do. And so when we can't figure out anything else, we want to start looking at different handouts. And so we're trying to get to where we have a combination where we have just a sine term. And so one of the things we see here, if we start looking through our trig reference pages, and these are available on our on the web page, so I encourage you to print your own copy of these, or at least have a quick link to try to get to these. Several things that we've covered already this semester. Law of sines, law of cosines came up in 2D vectors, those sorts of things. But we have these addition and subtraction formulas that work for combining terms into a sinusoid. So if I can hope that that thing works somehow, let's look at that. So what that tells me is that I'm going to try to develop an equation real quick. Again, this is stuff that wouldn't be on your homework section, but something we need to work out. And you need to be able to see it, so I'm going to write it on this same sheet. So sine of x plus y is sine x times cosine y plus cosine x times sine y. If I substitute and let x equal 2t and y equal phi, then I get sine of 2t plus phi equals sine of 2t cosine phi plus cosine of 2t times sine of phi. So now I'm starting to get something that looks like this. Or really, I could have said that that's omega t, and I just know that omega is 2. And then multiplied by a. So that gives me a times sine of 2t. I'm actually going to back this up. Okay, so backing up a little bit. I'm trying to combine these two things. I need to develop an equation. And so what we had was if we can only combine these two things if we have the same omega. And I need to develop an equation out of that. There's not a simple formula anywhere that tells me how to do that. And so I'm going to pull out the handy reference sheet. And these reference pages are available on our website. So you can go and look at those to help you with this. We've used some of these other things from trig in previous section, 2D vectors. We use law of sines, we use law of cosines. These addition and subtraction formulas, not obvious, but they do have kind of the form that we're looking for. We want to have sine of this plus that. If I try to make this sine of x plus y look like that, maybe that'll give me something over here on the right side that will work. So I'm going to use this formula that tells me sine of x plus y equals sine of x times cosine of y plus the cosine of x times the sine of y. Then I'm going to substitute that x is omega t and y is equal to phi. So then what I have is that sine of omega t plus phi is equal to sine omega t times cosine phi plus cosine omega t times sine of phi. Alright, so we're getting there. The other thing we're missing from this is a, so I then want to multiply both sides by a. So I would have a times sine omega t plus phi equals a times sine omega t cosine phi plus a times cosine omega t times sine phi. So now I've got what I want over here. I'm going to just rearrange. So if I just kind of rearrange this, I have a times cosine of phi times sine omega t plus a times the sine of phi times cosine omega t. So now I have an equation that kind of looks like what I want. I know, so once I've done that, let's think about this back in terms of v of t. V of t is equal to 6 times sine of 2t plus 8 times cos of 2t. And I know I want this to look like, I want that to look like a times the sine of omega t plus phi. Well, what things do I know? So if I start kind of matching up terms here, what I see is it looks like this times sine t and that times cosine works out. So it looks like, and I've said this before, I know my omega is 2. We have 2 times t. And I know that a cosine phi must be the same as this. It must be 6. And a times the sine of phi must equal 8. Because that's the part that I get multiplied by in there. And maybe it would have helped to give you kind of the in-between equation there. Then that means v of t, or a sine of 2t plus phi is going to equal, 6. Whichever way. Just recognizing that those equations start to match up. So now I've got 2 equations and 2 unknowns. Remember, I really need 3 parameters in order to set a sinusoid. I've got one of them. I've got omega. It was 2. That was easy to get, thankfully. Now I just need to get a couple of these. If I can get both of these, and I've got 2 equations, 2 unknowns, that should be easy to solve. Well, how would I ever solve that? Well, let's think about that a minute. What this really says is that cosine phi is 6 over a, and that sine phi is 8 over a. Again, we have to kind of imagine what these things look like. We kind of rethink things. We're engineers. So if I were to draw a triangle, and this angle is phi, cosine of phi is 6 over a. So that's the same as this being 6 and the hypotenuse being a. Sine of phi is 8 over a. So that's the same as this being 8 and that being a, which is good because I got there. So I could rewrite that and figure out that a, using the Pythagorean theorem, is just going to be the square root of 6 squared plus 8 squared. So a is equal to the square root of 100. So a equals 10. And that phi is going to be tan inverse of my opposite over my adjacent. So phi is going to be tan inverse of that, which is, if I punch that in my calculator, I get 53.1 degrees, or because I'm in radians, I might want to multiply that times pi over 180. And so whatever that is divided by 180, it's 0.295 pi, or I can go ahead and multiply that out. So a few different ways to get there. That are all possible answers. And a lot of times, because we like to see it with the pi in there in terms of being able to determine radians, we might include that in there. But now I've got my parameters. I've got A, I've got phi, I've got omega. So now I know that V of t is equal to A, which is 10, times the sine of omega, which is 2, times t, plus phi, which is, I'll just write it as a decimal actually, 9.27. And again, you may see that expressed different ways. You might see, or that might be 0.295 pi. Either way, you might express that. But that's one way we can get. We've now taken those two angles and combined them into one with the phase shift. And so that's something you'll see in electronics.